So to find the area of the inner loop of that polar curve, we're going to have to take that polar curve function set to equal to 0 to find out where it begins and ends. So solving for sine theta, we get 1/2, and so theta is equal to 1/2 at the angles of pi over 6 and 5 pi over 6. Using the graphing calculator to verify, graphing the polar function, and then tracing along to see that the inner loop is created from pi over 6 to 5 pi over 6. So the area is equal to 1/2 the integral from pi over 6 to 5 pi over 6 of the polar function, which is 1 minus 2 sine theta quantity squared d theta. Then using the graphing calculator to evaluate that integral, we get the value of 0.544, so answer choice A. For the next function, we're looking between the two curves. We're looking at the top angle at pi over 2, and the bottom angle is 3 pi over 2. Using the calculator to verify, just tracing along to find out that those two angles are at pi over 2 and at 3 pi over 2. So the area of R is equal to the integral of 1/2 from pi over 2 to 3 pi over 2. The outside polar curve, which is 1, so that gets squared, minus the inside polar curve, which is 1 plus cosine of theta, and that also gets squared. So you're taking your outside radius polar and minus your inside polar. Then using the graphing calculator to evaluate that integral, we get the value of 1.215, which is letter choice B. To set up the integral for the area enclosed by the region of that polar graph, it's 1/2 integral from 0 to 2 pi of the polar graph squared. Simplifying, the radical and the square cancel out, so we're left with the integral of 3 plus cosine of theta. To go from 0 to 2 pi is the same as, since we have symmetry, twice the integral from 0 to pi of 3 plus cosine of theta. So the 2 and the 1/2 simplify, and we're looking at the integral from 0 to pi of 3 plus cosine of theta d theta, which is letter choice D. To look at that area enclosed by the polar graph of R is equal to 1 minus cosine of theta. That's traced from 0 to 2 pi, so we have 1/2 integral from 0 to 2 pi of that radius squared d theta. Distributing, and then replacing in the double angle formula. And as we simplify, we antiderive to get 3/2 theta minus 2 sine theta plus 1/4 sine 2 theta from 0 to 2 pi, following the fundamental theorem of calculus, replacing in the 2 pi and the 0, get a final answer of 3 pi over 2, which is letter choice C.